All right, let's talk about Venus. Our closest planetary neighbor. We often call it Earth's twin, which sounds kind of nice, right? But believe me, this is one twin with a seriously dark side. We're about to peel back the clouds on one of the most extreme, most fascinating worlds in our entire solar system. So here's how we're going to break it down. First, we'll look at exactly why it gets that Earth's twin nickname. Then we'll dive into the shocking differences, from its insane runaway greenhouse effect to a rotation that is just bizarre. We're going to peek under those thick clouds, and then, most importantly, we'll figure out what this fiery world can teach us back here on Earth. Okay, so let's unpack that nickname, Earth's fiery twin. You hear twin and you think, similar, familiar. But the story here is so much more dramatic. It's a tale of two planets that started out almost identical and then, somewhere along the way, took wildly different paths. So Venus is right next door, cosmically speaking. It's the second planet out from the sun. When you see that super bright star in the early evening or morning sky, that's probably Venus. It looks so peaceful up there. But yeah, looks can be deceiving. We are looking at a world of absolutely unimaginable extremes. To really appreciate just how wrong things went for Venus, you first have to understand how similar it is to Earth. So let's start there. Let's look at the parallels that earned it that twin reputation in the first place. And this, right here, is the heart of it. Check this out. Both are terrestrial, meaning they're rocky planets, not gas giants. But look at the diameter. Venus is just a tiny bit smaller than Earth. It's uncanny. In terms of size and the stuff it's made of, it is the closest thing to a sibling planet we have. And the family resemblance goes even deeper. They were born at the exact same time, about 4.5 billion years ago, cooked up from the very same cloud of cosmic gas and dust. So that's the billion-dollar question, isn't it? If they had such a similar start in life, how on earth did they end up on such completely different paths? Well, this is where the story takes a hard right turn into some really hostile territory. The single biggest reason for the difference, the thing that really defines the Venus we see today, is its atmosphere.
Get a load of this number. The surface of Venus is a steady 900 degrees Fahrenheit, that's 475 Celsius, and no, that is not a typo. It is literally hot enough to melt lead. A commercial pizza oven runs at about half that temperature. This makes Venus, by a long shot, the hottest planet in our solar system.
So how is that even possible? It's all because of something called the runaway greenhouse effect. Basically, Venus's atmosphere became the perfect thermal blanket. It started trapping the sun's heat so well that the temperature just kept climbing and climbing and never stopped. Scientists think that any oceans Venus once had probably boiled away, which just pumped more heat-trapping gas into the air, creating this catastrophic feedback loop that, thankfully, Earth managed to avoid. And this is what's so wild. Take a look at this. Mercury is the closest planet to the sun, right? It should be the hottest, but it's not. Venus is consistently hotter. This is the ultimate proof that it's not just about how close you are to the fire. It's all about the kind of blanket you're wrapped in, and Venus has the thickest, heaviest blanket of all. So what's this blanket made of? It's about 96% carbon dioxide, the ultimate heat-trapping gas. And those thick, yellowish clouds that you see in pictures, yeah, they're not water vapor. They're droplets of corrosive sulfuric acid. Oh, and to top it all off, if you could somehow stand on the surface, the atmospheric pressure is more than 90 times what it is here on Earth. It would feel like being a kilometer deep in our ocean. Just crushing. The weirdness doesn't stop with the heat and the acid rain, though. Venus's whole sense of time is completely alien. You think a day on Earth is long sometimes? Well, let's talk about its rotation. Okay, brace yourself, because this is one of the strangest facts in the entire solar system. A single day on Venus, one full spin on its axis, takes 243 Earth days. But its year, the time it takes to orbit the sun, is only 225 Earth days. You heard me right. On Venus, a day is actually longer than a year. Just try to wrap your head around that. And as if that wasn't mind-bending enough, it spins backward. It rotates in the opposite direction of most other planets in the solar system, including us. It's called retrograde rotation. So if you were standing on Venus, you'd watch the sun rise in the west and set in the east. Everything is backwards. So what gives? Why the super slow, backward spin? Well, scientists are still debating it, but a leading theory is pretty dramatic. It points to a massive collision, some cataclysmic impact early in its history that was so powerful it basically knocked the planet upside down and slowed its rotation to a crawl.
So with all those thick, acidic clouds, we can't just take a regular photo of the surface from orbit. So how in the world do we know it's down there? Well, this is where some very clever engineering comes in. What lies beneath that blanket of clouds is a world forged by fire. Radar mapping has shown us a surface just covered in volcanic features. We're talking hundreds of thousands of volcanoes, huge plains paved over with ancient lava, and massive, towering mountain ranges. We can also see giant impact craters, scars from a violent past, all perfectly preserved under that thick, crushing atmosphere. It's a truly alien landscape. Our entire picture of this hidden world comes from missions like NASA's Magellan spacecraft back in the 90s. Magellan didn't have a camera in the traditional sense. Instead, it used powerful radar that could actually pierce through the clouds, bouncing signals off the ground to build up these incredibly detailed maps of what the surface really looks like. Okay, so we've looked at the scorching heat, the crushing pressure, the bizarre timing. After all that, you have to ask, so what? Why should we care about this failed twin so far away? Well, it turns out it matters a whole lot. You see, Venus isn't just a curiosity. It's a planetary-scale laboratory. It is our best real-world example of what happens when a greenhouse effect goes completely off the rails. Studying Venus helps scientists model how climates on rocky planets can change over time. And let's be honest, it serves as a pretty stark warning about how delicate the balance is that keeps a planet like ours habitable. And really, that just sums it all up, doesn't it? It might have started out as our twin, but it ended up as a world of fire, acid, and pressure. It's this incredible, dramatic case study of how two very similar starting points can lead to two profoundly different endings. And that really leaves us with one final, kind of chilling question. Venus is a cautionary tale, written across an entire world. It forces us to look back at our own planet and ask, what are the limits of Earth's resilience? And what lessons must we learn from our fiery twin to make sure our story doesn't end the same way?